Hello and welcome to C++ Weekly. I'm your host, Jason Turner. I'm available for code reviews, contracting, and on-site training. On this episode, I'm going to give you a bit of a quick start into standard ranges with a little bit of the why and a little bit of the how. And just for the record, this is not going to be very deep. So the first thing that I want to make you aware of is that they just give us this handy, tiny little adapter for our common algorithms. Now, let's just say we have this source of data and we want to do something with it. Like, I don't know, we just want to see if all of these things are less than 5 or something like that. Now I'm just going to go ahead and give you a second to digest this code and see what you think of it. There is a bug here, and it's unfortunately kind of a common bug, and as we can see, our compiler is not warning us about it. So let's just go ahead and see if we can get some sort of a runtime error. Interestingly, we are not getting a runtime error. Let's go ahead and turn off the optimizer and then see what happens. We're still not getting a runtime error. This is spectacular. Okay, so you may have noticed, first of all, that GCC was returning the wrong answer, and now Clang is returning, quote, the correct answer, but we are still not getting a runtime error. Okay, well, there we go. We actually had to enable glibc's debug iterator support to actually get a runtime error here. This is absolutely ridiculous, but here we are. So the problem was I'm getting a temporary back from this function, and then I was calling begin on the first temporary returned, and I was calling end on the second temporary returned. So these should have been a mismatched iterator pair, but coincidentally, they happen to be things that were allocated near each other in memory, and we didn't get any kind of runtime error. So yeah, that's exciting. But if you've encountered something like this before, you end up doing something like this. Well, that is, if you don't want a runtime error and undefined behavior in your program, but you know, what can you ask for? Okay, so this works properly. Now, the point here is that ranges actually gives us a handy little helper that we can do like this. And we no longer have to pass in this explicit begin and iterator pair. This just works, and that's really cool. So that's the first thing that we get. Now, the second thing is just this handy little pipeable range views. And you saw some of this if you watched my episode on finally a simple string split. Now, in this case, we can take a range and make a lazy evaluated view of it surprisingly easily. Now, unfortunately, Clang doesn't yet have full support for these things, so I needed to move over to GCC trunk. But as we can see, I was able to drop one element and take the next two. So I dropped the 2, I took the 3 and the 4, and then 3 and 4 are both less than 5, and the program returns 1 from main. If I were to update this to, say, drop 2 and then take the next 2, then I would be getting the elements 4 and 5. 5 is not less than 5, so we should get 0 returned from main. There we go. So handy, cool, little, adaptable, composable, pipeable views of things. Now, this is kind of my most favorite application. And it comes down to just this very annoying little aspect. Like, just say you want to do a ranged for loop over all but the first element of something. And, it may be perhaps it seems a little bit silly, but it's a problem that comes up during data processing more often than I would like for it to. Yes, now before you comment, I know that I could use a for each algorithm on this, but I know a lot of people don't like that for simple situations. And in this case, the argument still applies however you choose to actually iterate over the data. Okay, so just a very simple way of skipping the first element in a range of data. To me, this is incredibly helpful. And it doesn't have to be the result of a function. It could be something else that lives here already in the stack. And again, data processing things, it's often that you want to skip just the first element, and it's always been harder than it needed to be up to this point. Now, the fourth thing that I want to call out is this lazy evaluation has, again, interesting implications with something like the stood transform view. And this is something that I didn't really anticipate finding, but again, this gives us a simple solution to a relatively annoying problem in C++. Now I'm going to do a quick walkthrough of this just to explain what it's doing. But basically, what I've done is I've created this little lambda. This is my transformer, and it takes a single element. It is itself mutable, and it has this, which is its current index. And so each time this function is called, I return a standard pair that is of the first element being a size t, the second element being a const reference to the thing that was passed in. I'm using C++ 20's explicit template parameters for lambdas here because I really wanted that type. And then I instantiate this thing with the post incremented index, which is intentional, and the element via reference here. So then I have my arranged for loop, and I take in a const reference structured binding of the index and the element, and I take get data and I pipe it through this transformer that is a make index, and then I print out the elements. And as you can see, I have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 printed with the 10 elements that were in my view here. So I could, with no problem, do the similar kinds of things that we've already been playing with and just say, well, I just want to print out the first 5 elements. And these things are all lazily evaluated, and as far as I can tell, pretty lightweight for compile time code being generated. And again, go back to the previous episode on a simple string split if you would like to see more about that. So those are the main 4 things that I wanted to cover about ranges, hopefully just to whet your appetite a little bit. And just a couple of quick notes. They're all const expr capable, which again hints to the idea that we might be able to do something like const expr scripting engine, something that's been in the back of my mind for the last 5 years or so, but I haven't really had the time to execute that yet. And also, if you want this straight away and your compiler doesn't currently support it, or your library, standard library vendor doesn't support this, you can get ranges v3, or also you should be aware that C++ 23 has a ton more ranges capability being added to it. But again, this is the quick start to ranges. I hope this got you a little bit interested in looking more into this. And thank you for watching this episode of C++ Weekly. Be sure to subscribe, give this a thumbs up, and consider becoming a patron or a supporter of the channel, a member of this channel, or buying one of my books that's in the video description here.